Imagine a computer so powerful it can solve problems in seconds that would take today's fastest supercomputers millions of years. That's not science fiction, it's quantum computing. Unlike classical computers that process bits of ones and zeros, quantum computers harness the strange laws of quantum mechanics to process information in entirely new ways. From breaking encryption to revolutionizing drug discovery, quantum computing isn't just an upgrade, it's a total reset. In this talk, we'll explore how this emerging technology is poised to disrupt everything you think you know about computing, security, and the future itself. Today we will talk about how quantum computing will disrupt everything you know. So before we start, make sure to hit the like button and subscribe to my channel. 1. The birth of a new computational era. Quantum computing marks a radical departure from traditional computing paradigms. Instead of using bits that represent either a 0 or a 1, quantum computers use qubits, which can represent both states simultaneously thanks to superposition. This allows quantum machines to process an immense number of calculations in parallel. In classical computing, problems like factoring large numbers or simulating molecular interactions are often infeasible due to time and resource constraints. Quantum computing promises exponential speedups for such problems. Born from quantum mechanics, a field rooted in uncertainty and probability, quantum computing is inherently non-deterministic, and that's what gives it unmatched potential. With companies like IBM, Google, and startups like Rigetti and IonQ pushing the envelope, we're witnessing the early days of what many believe will be the most revolutionary technological advancement since the invention of the microprocessor. The world is standing at the precipice of a computation revolution that could rewrite the laws of what's possible. 2. Fundamentals that redefine logic. At the core of quantum computing lies quantum entanglement, a phenomenon where qubits become intertwined such that the state of one instantly influences the state of another, even across vast distances. This enables quantum systems to perform complex operations that are impossible for classical computers. Another principle, quantum tunneling, allows qubits to bypass traditional logic gates, solving optimization problems far more efficiently. This nonlinear behavior means that a quantum computer doesn't work faster by brute force. It works smarter by simultaneously exploring many solutions. Also, quantum gates manipulate qubits using reversible transformations, unlike irreversible classical gates, resulting in minimal energy loss. Because qubits are highly sensitive to their environment, quantum error correction and coherence times remain central technical challenges. Yet, even with these hurdles, quantum hardware is advancing rapidly, moving from noisy, intermediate-scale quantum (NISQ) systems toward scalable, fault-tolerant machines. 3. Breaking the cryptographic backbone. One of the most immediate and widely discussed disruptions of quantum computing lies in cryptography. Today's digital world relies heavily on RSA and elliptic curve cryptography, which are considered secure due to the impracticality of factoring large numbers using classical computers. However, Shor's algorithm, a quantum algorithm, can factor such numbers exponentially faster, rendering these cryptographic systems obsolete. Governments and enterprises are now in a race to develop post-quantum cryptography, algorithms that can withstand quantum attacks. If hostile actors gain access to powerful quantum computers, they could decrypt classified communications, steal financial data, and undermine national security. The NSA and NIST are already working on standards for quantum-safe encryption, but the clock is ticking. This looming threat has triggered a global cybersecurity arms race. In the coming decade, we may see massive overhauls in how digital identities, secure communications, and blockchain systems are safeguarded, all because of quantum's unique power to break what once seemed unbreakable. 4. Transforming artificial intelligence. Quantum computing has the potential to accelerate artificial intelligence and machine learning far beyond current limitations. Traditional machine learning often struggles with training complex models due to the computational intensity involved in searching vast parameter spaces. Quantum systems can enable quantum-enhanced machine learning by utilizing qubits to encode and process high-dimensional data more efficiently. Algorithms like the Quantum Support Vector Machine (QSVM) and quantum neural networks (QNNs) promise improvements in pattern recognition, optimization, and data clustering. This could revolutionize fields such as natural language processing, autonomous driving, and medical diagnostics. Moreover, quantum computers can simulate the probabilistic nature of neural networks more natively than classical machines. 5. Revolutionizing drug discovery. Pharmaceutical research stands to benefit enormously from quantum computing, especially in drug discovery and molecular simulation. Traditional computers struggle to model molecular interactions accurately due to the quantum nature of electrons and chemical bonds. Quantum computers, however, can simulate these interactions at the quantum level, providing unparalleled accuracy in predicting molecular behavior. This could slash the time and cost required to discover new drugs, vaccines, and materials. For example, companies like D-Wave and IBM have begun experimenting with simulating proteins and molecules to accelerate treatment discovery for diseases like Alzheimer's and cancer. Even complex simulations of how a drug metabolizes in the human body or how a virus mutates become feasible. Quantum simulations could eliminate years of guesswork and trial and error, allowing for more targeted and effective treatments. 6. Finance will never be the same in the financial world. Risk analysis, portfolio optimization, and fraud detection rely on sifting through vast datasets and running countless simulations. Quantum computing offers a major advantage here through its superior optimization capabilities. Algorithms like the Quantum Approximate Optimization Algorithm, QAOA, can solve problems involving thousands of variables, ideal for fine-tuning asset allocations or simulating market behaviors. Trading firms could use quantum strategies to predict market trends with greater accuracy, leading to massive economic shifts. Credit scoring, derivative pricing, and even the detection of systemic financial risks can become far more efficient. Large banks and hedge funds such as JP Morgan Chase and Goldman Sachs are already investing in quantum research. As this technology matures, we may see a paradigm shift, where traditional models of finance are no longer viable, and quantum-native models become the standard. 7. Rethinking logistics and supply chains. The global economy runs on intricate supply chains, where optimization of routes, delivery schedules, and inventory is critical. Classical computers often use heuristics for these NP-hard problems, which are unsolvable in polynomial time. Quantum computing offers a fresh approach. Using quantum annealing and hybrid quantum classical techniques, problems like the traveling salesman, warehouse layout, or cargo load balancing can be tackled more efficiently. Companies like Volkswagen and DHL are already running pilot programs with quantum solutions to streamline urban traffic and improve delivery logistics. In an age where disruptions from pandemics to geopolitical tensions can paralyze supply chains, quantum resilience could become a competitive necessity. From minimizing delivery times to maximizing fleet efficiency, the logistics sector stands to become leaner, faster, and smarter. This won't just reduce costs, it will also reduce carbon emissions and resource waste, making global commerce more sustainable. Quantum technology thus brings not just efficiency, but also greater resilience and foresight. If you like this video and would like to see more like it, please give it the thumbs up. Leave a comment and click the button to subscribe.